Here in this video, we are solving NEET questions from a chapter called Wave Optics or Physical Optics. One is of NEET 2020, another one is of NEET 2019. Both are Young's double slit experiment, interference concept. Let us see the first problem. What it says is, in a Young's double slit experiment, if there is no initial phase difference, that means initial phase is 0. Delta phi, initial phase difference is 0. Between the light from two slits, a point on the screen corresponds to the fifth minimum is, how does the experiment looks like? There will be a source, then there will be Young's double slit experiment, double slits. Both the slits acts like sources and waves will further go. These two waves will meet. Depending on how do the two waves meet, there will be on the screen a brightness or a darkness, right? So for the bright or dark, there is a phase difference between them, delta phi. It is rated with the path difference as delta x. Path difference is the difference along the path in two waves. The delta x is n lambda for bright spot, isn't it? Where n starts from 0, 1, 2, 3. That means for a path difference of 0, lambda, 2 lambda and so on. For dark spot on the screen, delta x equal to, we have derived this derivation. Please go through the physical optics chapter to know how we got this derivation. 2n minus 1 of lambda by 2, where n starts from 1, 2, 3 onwards. So for n equal to 1, 2 minus 1 is 1 lambda by 2. So first dark spot at lambda by 2 of delta x. In the problem, fifth dark spot corresponds to fifth minimum, that is fifth dark spot. For fifth minimum, n equal to 5 in this condition. That implies delta x equal to 2 times of 5 minus 1 of lambda by 2. That is 9 lambda by 2. So for a path difference of minimum 9 lambda by 2, there will be a fifth dark spot. That's how we solve that first problem. Let us solve the second problem. In a double slit experiment, that is Young's double slit experiment, when a light of wavelength 400 nanometer is used, angular width of the first minima is formed on the screen 1 meter away was found to be 0.2 degree. So what is angular width? We need to know. First of all, we can write fringe width beta as lambda into capital D by small d, where lambda is wavelength of that light, small d is the distance between the two slits, capital D is the distance between slits and the screen. That's called fringe width. Beta by d is called angular fringe width, how much angle it makes there. So theta equal to angular fringe width equal to beta by d, that is lambda by d. Now he is saying what will be the angular fringe width for the first minima if the entire experiment is immersed in water. So what happens? When immersed in water, theta dash will become lambda by d in water, that is lambda dash by d. Even when you immerse in water, distance between the slits won't change, but lambda wavelength reduces, waves comes close to each other in a denser medium. It becomes lambda by mu. That implies, and of course d, theta dash equal to theta by mu, irrespective of any other data. So theta is given for you as 0.2, refractive index of the medium is given for you as 4 by 3. So 0.2 into 3 by 4, that is 0.6 by 4, that is 0.15 degree. That's the answer for the problem. That's how we solve this simple questions on interference concept of wave optics. Thank you for watching.